Hello, in this session I am going to discuss about the basic thermodynamics fundamental concepts and definitions. In that I will discuss the thermodynamics definition and scope, microscopic and macroscopic approaches, some practical applications of engineering thermodynamic systems, characteristics of system boundary and control surface with examples. Firstly, we'll take the definition of thermodynamics and then we'll move for the other. Thermodynamics is a branch of science that deals with energy in all its forms and the laws governing the transformation of energy from one form to another. The forms of energy are mechanical, thermal or heat, chemical, electrical, etc. Thermodynamics deals with the behavior of gases and vapors, that is the working substances, when subjected to variation of temperature and pressure, and the relationship between heat energy and mechanical energy, commonly referred to as work. Energy transformation takes place when a substance undergoes a change from one condition to another in a process. The processes are heating or cooling and expansion or compression in the cylinder or passages with or without production or supply of mechanical work. Here thermodynamics actually deals with the energy transactions and from one form to the another form here with some considerations. Okay, those considerations are taken, then later what are these transactions are there we'll discuss. Continuation with this one, the study of this energy interaction may takes place with the two point of view or two approaches. Those are macroscopic and microscopic approaches, and these are also called as macroscopic or microscopic approach point of view also. In that first we'll take that is macroscopic approach. The description of a system or matter using a few of its measurable bulk properties constitutes a point of view called macroscopic. The measurable properties are pressure, volume, temperature, etc. The state or condition of the system is completely described by means of group of molecules or properties of the system. Such properties are called macroscopic properties, and these describe the system from macroscopic point of view or classical thermodynamics as. Here the group of molecules are considered. With these group of molecules the thermodynamic properties are defined. Therefore, by the thermodynamic properties or group of molecules, whatever the system we describe, that is a macroscopic point of view or macroscopic approach. Similar to that, the study of the behavior of system or matter described by summing of the behavior of each molecule or atoms or even electrons is called microscopic point of view or statistical thermodynamics. In this one, behavior of each molecule or atoms or even sometimes electrons are considered while studying, and total whatever the behavior of the system we are going to consider, their summing up of the all these behavior of each molecules are added, and this approach whatever is there, that is called as a microscopic approach or microscopic point of view, that is also called as a statistical thermodynamics. Some practical applications of thermodynamics, in that first one, steam power plant, which is important for the power generation. Here actually the heat energy supplied by the fuels is converted into a mechanical energy through a steam. How that is taking place? Here the energy source such as furnace, from that heat is supplied to a boiler where the water is converted into steam. The steam contains the heat energy in it. With a high pressure and temperature, the steam whatever is there, that is supplied to a turbine where it is expanded. That during expansion, the heat energy contained in the steam will be converted into mechanical work. The work will be converted into that one. Then whatever the expanded steam is there in the turbine, that is a low temperature and low pressure steam, is supplied to condenser where it is condensed to a liquid state, and the remaining heat is rejected to the atmosphere. Then whatever the condensate formed is there, water, that is supplied to a boiler once again. Okay, in this one, the continuously the heat energy will be converted into a mechanical energy through a steam. That is the application of the thermodynamics. The next application is IC engines. The internal combustion engine, where the chemical energy contained in the fuel will be converted into heat energy while burning inside the combustion chamber of the cylinder. That heat energy forces the whatever the piston for its movement, thereby heat energy will be converted into a mechanical energy, where the conversion of the one form to the another form is taking place. The next example is a gas turbine. The gas at a higher temperature and pressure, that is supplied to a gas turbine, and where the expansion of that gas is taking place by converting the heat energy of the gas into a mechanical energy. The shaft power is converted. Then that is another example of the thermodynamics, where the heat energy will be converted into a mechanical energy. Then here the thermodynamic, what we are going to study, in that the first thing where the energy interaction is taking place, that whatever we are going to consider, that is the thermodynamic system. For this, in the analysis of energy interaction, it becomes convenient to define or restrict a study to a region. In particular region only we have to restrict our study. A quantity of a matter or a specified region in a space where the transfer of energy and or mass is to be studied is known as a system or a thermodynamic system. And everything external to the system is called surroundings. Then the system and surroundings are separated by a line called system boundary. The system and surroundings together constitute a universe. Here this is considered as a system. This may be a quantity of matter or a region in a space, okay, in which the whatever our study is focused on this, and everything external to that one, that is called as a surroundings. That is called as a surroundings. Then here these surroundings and system, these are separated by a line called boundary or system boundary. Okay. Then next, here the system boundary whatever is there, that may be a real boundary or imaginary boundary, okay, or fixed boundary or moving boundary. Okay, here in this we will discuss real and imaginary boundary. That one, the real boundary, it is the boundary which is connected to a surface, okay, where actually the enclosed gas is considered as a system. That is the real boundary. Okay, here inside the internal combustion engine combustion chamber, okay, the whatever the gas enclosed, that is considered as system, and the boundary lines of that cylinder is considered as a real boundary. Then here, that is during the exhaust, the gas whatever exhausted, it will carrying some heat energy in it, and that is also considered for the system, for the studying the interactions, energy transfer, and there some line is drawn which is imaginary, that is not exact, that is a imaginary boundary, that is called as a imaginary boundary. And here that system boundary may be fixed or moving boundary, the system may have. Then the thermodynamic system what we have considered, that are of three types. The thermodynamic systems are three types. The classification of thermodynamic system, in that first one is a open system. The open system in which both energy and mass transfer takes place across the system boundary. Example, turbine, compressor. Here both the energy and mass transfer across the system boundary. In closed system, the second one, closed system, in which energy can transfer across the system boundary but mass cannot transfer across the system boundary. This is system of fixed mass. This is system of fixed mass. Example, internal combustion engine, piston and cylinder. Here in that internal combustion engine, the whatever inside combusted gas is there, that is having the fixed mass. The mass is not transferring, but the expansion of that whatever the burnt gas is there, that mechanical work it will supply. The mechanical energy it will transfer across the system boundary. Okay, that is the closed system. Then isolated system, the system in which both energy and mass cannot transfer across the system boundary. That is called as the isolated system. This system is of fixed mass and energy. Here the mass and energy both are fixed. Example for this one, thermos flask inverse. In the thermos flask, whatever the T inside is there, that will not transfer the heat across the system boundary. The mass is also not transferred when it is lid is closed. Okay, here this is the open system. Here the matter or mass and energy both interaction taking place between the system and surroundings. The second one closed, here energy only transfer across the system boundary. In third one isolated, there is no mass and energy transfer across the system boundary. Next, control volume or open system and control surface. In the open system, both mass and energy cross across the system boundary. There, where to fix the boundary? Both are moving. There, in the particular region we are going to restrict, that is called as a control volume. And the surface concerned to that one confined by that control volume is called as a control surface. Okay, in this system, mass and energy both may transferred between the system and the surroundings. Example for this one, gas turbine, steam turbine, compressor, boiler, etc. In this here example is taken as the gas turbine. Here the gas turbine, the gas is entering into the turbine, and after doing the work and converting the heat energy into the mechanical work, that is exhausted. And here there is a one line is drawn. Okay, that line whatever is there encloses the volume where the actual conversion of that one form of energy into the other form taking place. That is called as a control volume. The volume enclosed by this whatever the boundary is there, that surface is called as control surface. Okay, here by this way we can define the control volume and the control surface for the some of the thermodynamic systems where the mass is continuously flowing for the conversion of the energy. Here the some other examples with the concern to the control volume and the control surface are taken. There the boundaries, the imaginary and moving boundaries are considered. Here the control volume with the real and imaginary boundaries. The whatever this boundary is there, okay, with the surfaces of the system, that is called as the real boundaries. Where the some fluid is flowing, but we are restricting the some volume for the study, and that whatever the restriction line we are going to consider, that is the imaginary boundary. And here the control volume with the fixed and moving boundaries. Okay, the piston and cylinder is taken as the example. Here the line which is near to the wall, this is one fixed, that is a fixed boundary. As the piston is moving, this line is moving and the piston is moving. Okay, this whatever this volume is there, that is changing. That is the moving boundary. Okay, with this that we are going to consider the control volume and the control surface concerned to the open system. I will conclude here. I will continue in the next class with this